And we're back. This is Stu Miniman with wikibon.org, SiliconANGLE TV's live continuing coverage of the Open Networking Summit here in the heart of Silicon Valley, talking about network transformation, and excited to really talk about a startup here. So joining me for this segment is Emilio Billi, who is the founder, chairman of A3Cube, which came out of stealth just a week ago. So Emilio, thank you for joining us on this segment.
Thank you to you. Thank you for the introduction.
Great. So can you tell us a little bit? What is A3Cube, and how do you fit into the networking ecosystem?
Okay. A3Cube is a startup. It's a company that is born in May 2012, so it's very new. But it's the result of more than 5 years of my personal work with my team and so on in a stealth mode. And what is done? A3Cube developed a new shared address space-oriented interconnection that aimed to extend the PCI Express capability from the inside the box outside the data center. So to create a real PCI Express capable fabric. And why? Why we do that? Because as you know, there are a lot of interconnections that are very good. There are Ethernet everywhere, especially in the data center. There are InfiniBand. Why PCI Express? So the idea came to me, and I invested everything in this idea because at a certain point of my life, I would like to build a parallel scale-out storage architecture. There where the time people start to talk about SSD. So I would like to use SSD to extol the maximum power as possible. And I realize also that the new emerging analytics software like Hadoop use a parallel file system to aggregate these distributed disk among the nodes. There was one thing that immediately I realized. When you use HDFS, for example, HDFS use TCP/IP socket for the communication. So solid-state hard drives are really good because they lower the latency to access to the disk, especially locally. What's happened when you connect multiple of these boxes with SSD inside in a parallel way? The network became the bottleneck because the latency of the TCP/IP socket over the network is becoming higher than the latency of the disk itself. So there was something that was not good.
Yeah, Emilio, if I could just jump in there. So I mean, we've been talking to a lot of people here and talking about open networking and all of the open source projects and everything. I think that the general assumption is everything goes on Ethernet, and I mean you know the old saying it's Ethernet or Ether not. So there's what was the core deficiency that Ethernet couldn't solve, and therefore why you need to look at this alternative.
That was the key of our development because we realized that everything is driven by at least the TCP/IP. That is the key of the Ethernet. But the TCP/IP, as we know, is too high latency. So Ethernet is a standard, so we need to think about the standard. But this standard is too high latency. So the idea was, okay, don't think anymore to Ethernet, change the transport media, change the way how to communicate between the server, but don't change the TCP/IP socket. And this was our answer to the Ethernet. So join the old world of Ethernet that is 40 years old with a new approach that is coming from the PCI Express, that is new bus, without changing the programming model, but extolling the power of the PCI Express and the memory mapping in a completely different way. That was
so performance obviously is a key driver here. What kind of performance do you get compared to traditional network?
Let me explain just a little bit the mechanism so you understand why we achieve such kind of performance. PCI Express is a memory mapped bus. most of the people doesn't think about that. They think that memory mapping is coming from the past and stop. Really, we have inside our computer a memory mapped bus that communicate very efficiently inside the box. So the idea was, take this mechanism and use outside the box in a way that to offload completely the operating system from the communication and use this new mechanism to put inside a virtual TCP/IP that permit to communicate server to server without using the kernel of the operating system. So the result was, for example, the standard TCP/IP used the kernel operating system, very high overhead. And you, for example, for 64 bytes, you can have, in the best case, 20 microseconds. With our approach, same benchmark, standard benchmark, you can achieve 2.5 microseconds. So, more or less 10 times less latency without changing the programming model.
Okay, so make sure I understand this. So, much better latency, much higher performance. Do I have to change my application? This limited to certain applications? So it does change the application stack.
You don't have to change.
Oh, no, you don't.
No,
okay,
you don't. You don't change. At least if your application are written for TCP/IP socket.
Yeah, which just about every application is.
So
okay, no, that's great. So it's it needs to be transparent to the upper layer protocols there. So I guess one of the other things, I think this has been tried before.
Yes.
This is not the first time we've tried to extend the bus. There's been many times there. There's a whole, just such a big ecosystem that's worked on Ethernet and other protocols for so long. How do you replicate things like security and reliability that we've done?
There's another step. In extending PCI Express outside the box, we realized that we need something that was really stronger than standard network. Also because in-memory operation are more critical than standard message passing. So the idea was to take the PCI Express and adding some feature that coming from avionics and military space, like, for example, end-to-end flow control, traffic congestion management, and flow control at link level. So we can manage it in a very, very deeply way all the traffic inside the network from 2 points of view. The first is hardware level. So a layer in hardware provides the basic flow control of the network. After that, we can access with the software to all the register of the devices connected together because of the address space, and we can change in real time, so we can act as a software-defined network to change, for example, the route in case of congestion or in case of link failure. And this was to upgrade the reliability of the fabric of the PCI Express to a level that can be considered a carrier-grade fabric.
Okay, can you talk to us a little bit of how scalable is this environment?
Okay.
With the bus architecture, I have to think that there's some severe limitations on distance.
Yes. Okay, of course we are talking with a very high-speed bus, so the copper is a limit, and now we are working to the optical interface. So imagine that you can reach without losing signal with standard PCI Express Gen 2 kind of SerDes or Gen 3, we can reach up to 5 meters in cable, copper, and maybe 100 in optical. So we adopt a new kind of topology that's coming from supercomputing to avoid the limited length of the cable. And this topology is the 3D torus. So each card contains itself a micro switch inside, so you can connect the server together with short cables, just one with another, like in a Cray supercomputer. So really, to cabling 1 rack or 2 rack or 3 rack, we don't need a really longer cable. The maximum length of the cable is when we want to go from one rack to another one, and that's it. We don't need to reach 100 meters of length of the cable. And this permits to us to scale with this topology. Also, we don't have the support for longer cable yet. And so you can cabling 10 rack of 40 nodes using the maximum of 5 meter cable. Of course, by June we'll be ready also with optical, and we assume that with optical we can scale up to 100 meters and so go ahead. The maximum scalability of the network is driven by the address space, and we use a 16-bit address space. So it means 65,535 nodes. And this is the maximum scalability we can reach. Of course, this is the theoretical one, because you have to take in consideration many other stuff. But we can say that we can at least scale without any problem at least at 10,000 nodes or more.
Okay, that's great scalability.
Yeah.
I guess the next question is, I mean, does this replace all of your networks, or do I still need to have, you know, a different network for some of my other traffic?
Okay, the idea behind this architecture was to create a very analytics and parallel storage architecture. So the idea was to act as a data plane. So imagine to have, for example, you want to build an Hadoop cluster. Hadoop cluster requires that the storage and the CPU are merged together. And then you want to connect this node that contain disk, CPU, thousands of these nodes. Okay, you can do using your own data center network, or using Ronnie, you can create a connection between these nodes and create a very fast data plane between a node to aggregate the file system in real time, to have extremely low latency if you want to extol SSD performance and so on, but also for the communication between the CPU, like in a supercomputer. Then you can use your data center network completely unmodified to access to this Hadoop cluster without changing your IP policy, without changing your firewall, and so on. Because when you have two different networks, like in, for example, Ethernet and this, the PCI Express, also if the programming model is compliant, the plug are not compliant together, so how to match? The idea was the separation between a very high-speed network behind the scene and the standard data center for what you have to communicate in terms of data access and read and write.
Great, so you mentioned Hadoop clusters a couple of times. Is that kind of the first use case for your environment?
Yes, was what we are focused, because there are two main applications that we are really focused on, where we can really extol the performance. The first one is analytic machine like Hadoop or Storm, and the second one is a very high parallel NAS. So instead to put the analytics inside, you put the computation outside, but you access concurrently to a global file system like in Hadoop. So it's a very close application together. And the reason, because we focus on that and we use a supercomputer style network, is because we are convinced that in the next year, high performance computing will become high performance data. So our life will be driven by data.
Yeah, so I mean, Wikibon CTO David Flair's talked a lot about how, you know, the HPC model is, you know, really, you know, impacting lots of architectures, especially, you know, when you look at things like Hadoop. So definitely see that proliferating some. You know, what's your, you know, ideal customer? You know, what market segment are you hitting? We can talk about your use case. Is this kind of a large enterprise service provider? You know, where are you kind of looking to find your first customer?
As a company, we would like to be vertical, so we target OEM and system integrators that can provide our solution. Of course, inside there are some market niche that are really perfect for our application. Maybe oil and gas application, for example, genomics, proteinomics, and in certain way also high performance computing in a traditional way, for example, fluid dynamics and so on.
Yeah, and it's interesting because I've actually had some conversations here at this show that there's some of the SDN solutions that are very much targeted. Oil and gas is a high one, you know, really low latency applications.
Absolutely.
That we can change the model. You know, how much of your team is, you know, focused on the software piece? How does software fit into you know, your overall solution?
So our team is divided half and half between software development, in terms also of design everything inside our card and so on, and hardware development and software development. We are complementary, we are divided exactly in half, and the software development is really focused on create a very robust in-memory library that permit two things. The first one to support the existing application, and the second one to find a new way to use this network for more and more powerful application for the future.
All right, so Emilio, we're getting the hook. Really appreciate you coming out, founder, chairman, and chief development officer of A3Cube. Very interesting technology, startup, definitely go check them out. Thank you for finding time, and we will be right back with our wrap up of Open Networking Summit 2014.
Thank you.